Hi, welcome to Topics in Euclidean Geometry in the fall semester of 2026. The course code for this class is Math 5330 or Math 5830, depending on whether you're taking it for undergraduate credit or for graduate credit. This is our first year with this new course numbering system. I'm going to slip up on occasion and refer to it by its old name, which was Math 533. Okay, in this video, I'm going to do three things. I'm going to introduce myself, I'm going to introduce the class, and I'm going to talk a little bit about the nuts and bolts of how this is going to work as an online class. Okay, let me start by introducing myself. My name is Dr. Lisi, and my office is Hume 318. If you come see me in my office, you'll recognize where we are because this is where I'm recording my videos. And my email address is stlisi@olemiss.edu. And that's the best way to get a hold of me if you have questions or want to schedule a meeting. I do have office hours. Those are listed in Blackboard. I haven't finalized them at the time of making this video. Okay, so what is Euclidean geometry and why do we study it? Euclidean geometry is named after Euclid. Euclid was a Greek mathematician who, roughly around 300 BC, wrote a treatise called The Elements. The Elements has 13 books in it, and the first 6 books of the Elements deal with geometry in the two-dimensional plane. So the geometry, for instance, of my blackboard here. The remainder of the Elements focuses on elementary number theory. Well, it's now called elementary number theory, and also on solid geometry. We'll focus on the content of those first 6 books where we're thinking about plane geometry. Okay, until the 20th century, anybody in Europe or America who had a classical education would have engaged with Euclid in some form or other. People with a strong Greek background, for instance, would have read him in the original. There are various Latin translations and, of course, translations into English and French and German and whatever. So people studied Euclid, and some famous examples include President Lincoln. Abraham Lincoln, in his autobiography, says that he studied those first 6 books of Euclid when he was a young lawyer in order to improve his argumentation skills and his ability to use logic. President Garfield also was a pretty serious amateur geometer. He, as a matter of fact, came up with his own proof of the Pythagorean theorem. And many, many other people of those eras would have been familiar with Euclid. And to this day, Euclid is an important part, or I should say geometry is an important part of the secondary school curriculum. So why do we call it Euclidean geometry and not just geometry? A key thing is this is not the only kind of geometry. So especially starting in the 19th century, starting with Lobachevsky, Gauss, Bolyai, and then Riemann, and then later mathematicians, people started being interested in the geometry of curved surfaces. Now, there's a very famous curved surface that many of us are interested in, right? The geometry of a sphere. The surface of the sphere is not covered by Euclidean geometry. So there's a rich theory outside of Euclidean geometry, and so even though Euclidean geometry is no longer an area of active research in mathematics, it has had many children. And there are many subdisciplines of mathematics that trace back to geometry, notably algebraic geometry, differential geometry, topology, to some degree group theory, and there are many, many other branches of mathematics that have at least some of their roots coming out of geometry. So why study geometry? I have 2 answers to that. A number of you are education majors. You're studying math education. And of course, geometry is a class that you may be called upon to teach. So this class will give you a solid background in geometry and a solid underpinning for the high school class that you may teach eventually. For the math majors in the crowd, this class will give you a nice gateway between our sort of computational and algorithmic classes, so for instance, the calculus sequence, a gateway from that into the more theory-driven, concept-driven, higher level classes like the topology class or the advanced calculus class. So in that sense, it's a useful intellectual bridge, both from a historical point of view and from a development of the concepts point of view. Now, everybody will benefit from this class in that it'll help you learn how to write mathematical proof better. It'll teach you to wrestle with mathematical definitions and think about why we make the definitions that we do. And will also teach you to think like a mathematician. In that sense, that's a very sort of creative process, but a process that's also not natural. So hopefully this will help you develop those skills along the way. Let's talk about the ingredients of the class, the nuts and bolts, if you will, of how this class is going to operate. We're going to have weekly videos and readings that will be assigned and posted on Blackboard. We also have a weekly Zoom meeting that's going to be on Monday afternoons. Attendance is optional. I'm going to record it and make it available to you on Blackboard. But I do encourage you to attend. It'll be a great opportunity for us to do various group activities and also address any questions you might have. We will have weekly homework. And as you might recall from before, we have this class is open to both undergraduates and graduate students. The homework, there'll be one homework assignment every week for the undergraduates. And that same homework assignment plus an additional grad student homework assignment will be assigned to the graduate students. All right, so the undergraduates will do one homework assignment a week, and the graduate students will do 2 homework assignments a week. We're going to have 3 written exams. These are going to take place at a university testing center, either the one here in Oxford or one of the ones at the branch campuses. That's up to you to schedule and organize. We're going to have the midterm tests after each of our first 2 modules of the class, and then the final exam will be after the 3rd module of the class. Each one of them will have a booking window, and we'll talk a little bit more about that in a moment. Roughly every 2 weeks, I'm going to ask you to contribute a question for class discussion. And I will give you more details about that when the first one is due. And then finally, there's going to be an end of semester video project. And I'll say a little bit more about that a little bit later in this video. The course content is going to be structured in 3 modules. The first module is going to be roughly 5 weeks long, and that is about axiomatic systems. This will be very much following in the footsteps of Euclid, and we will also touch on a classically very important question and problem, the one about the parallel postulate. Module 2 will be about transformations. And in this, we're going to be heavily influenced by the mathematician Felix Klein, who in the 1880s proposed looking at things from a transformational point of view. This is a very rich perspective that has led to a lot of contemporary mathematics, but also is considered to be very important in, for instance, in the Common Core standards or in the Mississippi college and career readiness standards. So the transformational perspective is a very contemporary one and very important. And finally, module number 3 is going to be about similarity. So you know this as similar triangles. We will look at things in that context. And this will include maybe the most famous theorem of all time, the Pythagorean theorem. It also is the machine that makes trigonometry work, and it also is the underpinning of many of the applications of geometry to the real world. Notably, it's the conceptual idea that allows, for instance, surveying to use geometry, and also people use it in construction sometimes. Each of these three modules will end with a written exam, as I've said. Module 1 will have midterm 1 at the end of it. Module 2 will have midterm 2 at the end of it, so that's 5 weeks, 5 weeks. Then we'll have 4 weeks of similarity, and then the final exam, which will be held during exam week. The class assumes that you have a prerequisite background of some knowledge of functions and mathematical logic, some basics of set theory, some idea of equivalence relations, things like that. This content here, we teach it in the class formerly known as Math 305. Now I believe it is 3050. If your background includes these topics, but you don't have the class on your transcript, that's not a problem. Just contact me and we will see about waiving the prerequisite if it's appropriate. Also, I'm going to do a review of these topics in week 2. So if it's a little bit rusty, that's okay, but you do need to have seen these ideas before. Okay, for all of the ins and outs of my course policies, I'd like you to take a look at the syllabus. That has everything in gory detail. But to give you a super short summary, first of all, this is a class open to graduate students and undergraduates. The undergraduates have 1 homework assignment a week, but graduate students will have 2. The exams will have some number of questions for the undergraduates, and then graduate students will be expected to do 1 or 2 more questions than that. It'll be clearly indicated on the exam paper. And in both cases, the undergraduates in the class can do the work that is assigned to graduate students for a little bit of extra credit. Okay, and then finally, right, I mentioned we have a video project at the end of the semester. The video project will have a little bit of a write-up with it. I will expect the graduate students to have a more in-depth write-up. And I will give a lot more information about that a little bit later in the semester. And we have the written homework. There's some policies about the written homework I want to mention. The first one is that I have basically an automatic extension, because it's not directly automatic, but you have to ask for it, but a no questions asked extension. So the homework will be due on Wednesdays in general. If you email me before the deadline, I can give you an extension until Sunday. Of course, if you have a good reason for needing an extension, you can email me with your reason instead. The key thing, though, is that I have a resubmission of up to 3 homework problems in the semester. What that means is, let's say you submit a homework assignment and you are not happy with how one of the homework problems went. You can rework it based on the feedback I will have given you and resubmit that. That allows you to replace whatever score you had on that first incarnation of that homework problem with whatever the new one would be. The point of this is to encourage you to write and rewrite mathematics. Writing mathematics is very hard. I remember myself struggling with it when I was an undergraduate. And I want to help you improve your writing skills of mathematics, organizing a proof, saying things correctly, and things like that. It will come to you, and it will click, but we have to get there. There's a famous anecdote in which King Ptolemy of Egypt, so Euclid was working in Alexandria, so King Ptolemy of Egypt came to Euclid and wanted basically the royal fast-tracking into geometry. And Euclid told him there is no royal road to geometry. And what Euclid meant by that was that King Ptolemy would have to work and labor over the geometry just like everybody else. Now, I'm here to help you along that road, but you're going to have to make progress along that road through your own effort. And I know this sounds corny, but there's a lot of truth to it, right? And that's what this three homework resubmission is to help you with. Okay, let's talk about exams. We're going to have 2 midterms and a final. These are going to be held at the Testing Center, or if you're on a branch campus, you can do it, for instance, in Tupelo or Boonville or one of our university branch locations. Details of how to book it are listed in the syllabus, so do take a look at that. And the link for scheduling it is on Blackboard. I encourage you to book early. We have a 4-day testing window for midterm 1, a 4-day testing window for midterm 2, and a 5-day testing window for the final exam. I draw your attention to the fact that the testing center is only open during university business hours. So if you have a problem scheduling a testing appointment, email me as soon as you can so we can sort out an alternative testing arrangement. The class includes an end of semester video project. I'm going to ask you to submit that on Monday, November 30th. That's the Monday right after the Thanksgiving break. And you can do it either in a group of 2 or you can do it by yourself if you prefer. I will give more details about this later in the semester, but basically you're going to make a little video about a topic. You're going to have a little bit of a write-up, and you're also going to watch then in that last week of the semester, you'll watch a few of your classmates' submissions and give some comments, feedback, that kind of thing. So let me recap the rhythm of how this class is going to look like. On Sundays around noon, I will post new material. This will be, for instance, links to videos, links to reading material, that kind of thing. But also, I will post a new homework assignment. Then on Monday, we will have our Zoom meeting. On Wednesday, well, I have my office hours that I haven't posted here, but the homework from the previous week will be due. And then, of course, on Friday, I have office hours again. And then the next week, again on Sunday, new material posted, new homework, Zoom on Monday, but then the previous week's homework will be due on that Wednesday, right? So this homework that was posted here in week N will be due on Wednesday of week N+1. So that gives you about 10 days for each homework assignment. Okay, and then something I didn't put on this diagram is roughly every 2 weeks, I will ask you to participate in a Blackboard discussion prompt. It's typically going to be a mathematical question that I'm going to ask you to come up with. But like I said, I will give more details when it's time for the first one. Are you ready? Okay, so for week 1, we're going to look at 2 examples of geometries that are not Euclidean geometry to help give us a framing of what Euclidean geometry is by looking at what it isn't. So we're going to look at 2 things. We're going to look at spherical geometry and taxicab geometry. So I have a video about spherical geometry. Actually, I have links to several videos. One of them I made, and several that are from other sources. And I also have links to some GeoGebra experiments that you can do to mess around with it. And then I have a link to an interactive New York Times feature on taxicab geometry. Exceptionally, we have both homework 0 and homework 1. And just to draw your attention, if you're a grad student, that means you have 3 homeworks to submit on CrowdMark already here in week 1. Okay, thanks for watching, and happy mathing.